I have the pleasure to bring the main approach a little step deeper. So this is, you heard a lot of things and approaches already from Ulrich, and I try to give you now the concept where we are following, and then comes the argumentation, and then comes the methodology. Always one step deeper. This is the idea of our morning phase. So, the main approach. You've already seen the goals which presented Ulrich. I want to explain it a little from deeper from this side. What meant feasibility for us? Of course, the structuring of the ODD. And what also was important is when we later on get into tests and so on, we want to exactly know what kind of claim, kind of rule do we have to consider and to prove. For example, the traffic laws have to be concerned inside this. Have to be part of the structuring of the ODD. This is strong part of feasibility. Next part is the consistent interfaces. I'm tier 1. So for us, as Michael already mentioned, it is really, really important that the interfaces in the industry matches. And interfaces not only the plugs, it's in our case safety cases, safety requirements and so on, which have to be consistent to the others. Really, really important that we scale up with this. Yeah? Efficiency, simulation, Ulrich already mentioned. You heard about Set Level. Set Level developed the simulation for automated driving. Our goal was not simulation. Our goal was to develop. Our goal was to bring it seamless into the tests, because only if we are able to use the simulation seamlessly between all the other artifacts, we are efficient. Goal 3. And the next one, it was on the corner on Ulrich's slide, here in the middle. It was implicit. In the beginning, it was not our goal, but it was clear that we have to explain the safety to the society. Yeah? It was for all clear, but later on we mentioned out we have really to concern that it is explainable to different stakeholders, and that is a strong goal for us. Yeah? So that was the goals. Michael already mentioned that we have a big complex area. What do? First of all, we keep the things which are already harmonized and fixed and look, okay, what is already clear? And one thing is that we have to concern, if we talk about safety for the overall behavior. If you take off the driver of the system, all the functions we typically assess separately have to be measured and to be evaluated together. And this is the behavior of the system. So the overall behavior of the system is, in the end, the most crucial aspect for safety. Point 1. Point 2, already mentioned, I steal this scale also from Thomas Kirschbaum. We all steal our slides. Is the absence of unreasonable risk. What does it mean? We have already automated consensus that we can express safety by risk. This is also one of the pillars we base on, because then we can handle safety. Yeah? That is the second pillar. Here, with the scale, I explain it in a minute. And also very, very important is how do we match up then with the scale? The society gives us the thresholds. The society tells us what are the meters, what are the acceptance criteria to measure the scale up. This is the idea where we follow. Make it a little bit tangible. You have a pedestrian stepping suddenly on a road, you have to brake immediately. Yeah? Measure, also known one of the biggest measures is use of technology, braking system, steering system, and so on, you imagine. But what is the acceptance criteria? The acceptance criteria is coming from different stakeholders, from different rules. Yeah? The product liability, product safety, the traffic rules, every of these societal concerns tells us about the acceptance criteria. In this case, they tell us we have to brake immediately and as much as we can, but at least as typical human driver is able to. That's the gamma principle. That's a little more sophisticated, you know, the system from the there are several systems which now oriented not on the typical but on a fit driver. Yeah, but now we go not too into details. But there are other acceptance criteria, as for example, we have to use the best technology available and practical. This is the Allah principle, which also is the societal acceptance criteria. And this is really important. And now comes the first conclusion. This is that the interaction has to be modeled. We have to model the risk. If we don't do, we cannot handle the risk, we cannot handle the safety. Yeah? This is really important, one of the steps you hopefully take with this slide. And now I try to briefly bring more deep what Ulrich already said. What is then our main approach? We base fully on Pegasus, on the Pegasus approach. But Ulrich already mentioned that there are a lot of, we have billions of kilometers and we don't want to exchange them with billions of test cases because the parameter space is too high. Yeah? So the idea is take less, as you already told, and then what we want to do is we want to argue, systematically argue that the behavior of the system is safe also in not only in the test case where I tested it, but in the bigger space. Of course, this is multidimensional, you understand. This is what you see here with these arrows. And you see on the depicted example, different velocities from the pedestrian, for example, may express these fields, what we like to spread out. And the idea is that the complete ODD is covered, argued by our argumentation. Yeah? And already in the slide you see design and verification validation. This is what we need. We need all the evidences from the design and the verification validation to have evidences for an argumentation that this space is really safe. For example, I know that a traffic light has a several spectral range, and I am able to percept all the stages of a traffic light. I can argue with this. Yeah? That's simple. Yeah? So the idea is everything what we have in the design and then use in your argumentation and spread off the space and cover the ODD with this. That's the idea. Once back. But argumentation is it's just a word, but in our terms it means that we have a real strict format which forces us to keep all things and that we have, for example, refutations against an argument, so it keeps us to be very precise in arguing. And this is, let's say, kind of like a strong sword. And now I try to bring it a little more on detail how it works. How to expose, extrapolate safe behavior areas, and also how to use already known automotive processes. As I explained at the beginning, we have these sensitive areas. So these sensitive areas are not so easy to find. How can we find them? we have to decompose the ODD. That's what Ulrich already mentioned. And we decompose the design. That's what we did the whole time, yeah, in different hierarchical stages of the system. And when we match them together, we find sensitive areas. We find, okay, in this area, under this weather conditions, a LiDAR had a problem. This is a sensitive area, yeah? And there we want to test. So when we have this, we need a risk model. Here, as it's written, we need a risk model, because not every match between a LiDAR is not working good means that there is a risk. We have to follow the risk. Where is the risk for the complete system? If not, we have enormous test space. We have to follow where is really risk. Yeah. Decomposition, ODD, matched with the decomposition of the design, following the risk model. Yeah? And then we need extrapolation models, yeah, for the safe behavior, and we define performance thresholds. We always did this in our work. Performance thresholds is the verification, is the specification of the system, for example. Yeah? That's what we already use. Yeah? But these have to be defined that the risk model is fulfilled. That's the difference. And as I mentioned, we need the risk model to do this. And what is the second step? The second step is verification and validation. You see here ODD and design is spread it up. Yeah, we look at the different areas, and the idea is that we do verification as much as we can do, and then we have to do the validation. This is the idea. Of course, there are limits. Yeah, there's a certain point where it makes sense to uncover the unknown knowns, yeah, then it's better to do the validation, yeah. So, but to a certain stage, we do this, and this is just our approach, yeah. Here on one slide is to go there and have this separation, this matching, and then the fulfillment of the thresholds. So, that sounds easy. Maybe it sounds easy. But now comes the second problem. Ulrich, he said, okay, brute force is not a key. Then billions of measurements and billions of scenarios is also not possible. But an endless argumentation, also not. Because yes, we can say, yes, we argue. But then at the end, our engineers sit hundreds of hours and they never find an end to argue. That is the third problem which appear. And that's what we want, what we have to avoid. How do we do this? We have to follow the argumentation concept from the beginning. We have to know what is the idea of an argumentation. An argumentation needs different perspectives. And we take as aspect the behavior, because the behavior is the crucial element for safety. So we have required behavior and we have specified behavior. We all know as technicians there's a difference. Yeah? That's the implementation gap, the specification gap. We have the real behavior in the real world, and there's also a difference. That's the implementation gap. And then, from the required behavior to the real behavior, it's the validation gap. And of course, we try to bring these together, all these circles, but it's not possible, and it's not useful to bring it completely. We have to follow the risk. We have to follow where is a risk if they are not matched fully. That's important. We don't have to bring it completely. That's not a way. We have to follow the risk and be selective. And what does it mean for us to have no endless argumentation? We need to configure our framework of development in the way we need later on for the argumentation evidences, because the argumentation need the evidences from our development and the V&V process. So we have to look that our V&V and development process is built up according to these requirements. And this is, we call it the capability layer for the composition of the abstract requirements, the engineering layer, the well-known process area of automotive, where we want to plug, and of course the real-world layer where we say, okay, we have to really test outside in an uncontrolled area, as Uli already mentioned. Not controlled, uncontrolled area is important for validation. Again, you've seen this maybe now with this slide now a little bit more familiar. This next time, these three layers you see, what do they mean? The capability layer, the composition of abstract requirements, required behavior. Really important is that from the beginning of the development, that we focus, that we have all the requirements, all the legal claims already in. And also, for example, when we need to verify and validate something later on, for example, we have to monitor the behavior of our system, it has to be planned already on this high level. You cannot later on come on and say, okay, I need to bring some ROMs on there and some chips to get information. No, you have to plan it from the beginning, because there are data spaces behind, there's knowledge behind everything. You have to plan it from the beginning. And only when you have a full concept that you fulfill the requirements of the society, you can define a required behavior. The next thing is, the example is the behavior here. For example, we need to define a behavior of the system really early. So we have to specify the behavior really early. For example, the thing I already mentioned before. It has to be clear on this side that we fulfill the requirements of the traffic rule. We need to fulfill the requirements of the ethic commission in Germany and so on, with the behavior which is defined on this layer already. The next thing is the engineering layer. You all know this. What do? We have to define the technology. We have to define the test space. A lot of presentations come later to this. And the third thing, already also mentioned, is the real-world layer. And I picked it up you have the combinations of all this stuff without having control is really, really important. So these three perspectives of the argumentation enable that later on we can argue, because we have these argumentations, this perspective, these three perspectives of behavior within our system developed, so we can use it as evidences in the argumentation. That is the idea behind. And of course, we looked at it the whole time that we use automotive processes, not to go far away from this. That's not possible. So this is an explanation of this layer. You will get more. And now, again, when we have this one, verification and validation and the design process ordered, we have also, it was Helmut Schittenheim later on, will explain really deeply the question how we use, how is our way then to bring this together with the decomposition of the ODD, with the scenarios. And also extremely important is the risk management. Thomas Kirschbaum is unfortunately ill. The speech is recorded. I stole a lot of slides from him. This is the risk management, and of course then which leads to the argumentation, which is the part of Jan Reich, come directly after me. So, but they have to be linked together. Check. And we say that it's really important that we keep these parts separated, that risk is risk, and verification and evidences are on this side, and so on. And they all support the argumentation. This is the idea. And now again, I come to feasibility. Now again, I come to let's say, the hurdle we see. We can endlessly argue that's not possible. And we concentrate that we avoid an endless argumentation. And what are some important elements? One important element is that we don't, or that we use consistently metrics which are able to transfer one representation to another. So in the first step, we have the operational concept and stakeholders, claims, rules, and we have to transfer them into top goals. We have to sort this, not to have a widespread of claims. That's not it's impossible to argue widespread of claims. You have to sort it. You have to say, okay, this is the same. NHTSA and the Ethics Commission have a lot of orderings which are more or less the same. We have to order this because we don't want to argue it twice. Yeah? The next thing is, now we have to bring all these top goals, safety and agility. Is a car should provide mobility. Agility is also a top goal, and we have to bring it together in a behavior. But this is an overall and a consistent behavior, and then we can prove, and later on come on to this, that all my top goals are in the behavior. And later on, all my top goals are, or all my claims from society are in the top goals. In such way, this goes on. We have to transfer in capabilities to behavior. So what does this behavior need the capabilities to drive? And then later on, how can I prove these capabilities? And I use metrics, this is really important, which are consistent. If not, we cannot argue. So the idea is now reproducibility. That's what I already mentioned. So I have to argue back that all the claims from society are inside my top goals. Then I don't care anymore about the claims of society because I already did this. That's important. Not thousands of different claims, top goals, because the top goals contain all the claims. The next, of course, is the target behavior, as I already mentioned, contain all the top goals. And I will argue this. I don't want to argue later on from some certain piece of my product that such a claim is fulfilled. I just do it stepwise. This is the idea. And the next thing is the capabilities. I can argue that these capabilities of the vehicle fulfill or the behavior, can express the behavior. And of course, that all the VMV concept will cover all the capabilities and the behavior. If I do this, I concentrate always in every step on the step again, and that's it. Not from the last time of the VNV that I look, oh, there is SOTIF number 300 and so on. No. Because this leads to an endless argumentation. That's what we want to avoid. So feasibility comes up if we really concentrate always to argue stepwise. Use the metrics, and found here objects which bring reproducibility. And this brings me to the summary. Again, we use the decomposition of our product and the decomposition of its verification validation. We bring it together with the decomposition of the ODD. We do this along a risk model, which is defined by the society or which gives the controls from the society. And we bring it together to an argumentation. And important is that these things are, on one hand side, separated, and as I told with the example, are strongly connected, so that the last was the example from these argumentation steps. They have to suit to the argumentation. Means that these design and verification, these three have to suit to the argumentation. That's what I explained. And this is also valid for the other fields. For example, for the decomposition of the ODD, you will have some speeches then later on which tells about this. So also the decomposition of the ODD is aligned to the ideas and to the structures and the strict format of the argumentation. And the same is valid for the risk management, because all of these fields we have to argue. And that is the approach. And we had these 4 goals, and we are convinced that we really catch up with these goals, because we can explain it to the society, because we use a format which is able to. That's the argumentation. Yeah? We have the feasibility, because we have a way to really concentrate on the risk points of the ODD. We bring the simulation inside, because we use consistency metrics and changeability, often forgotten, but in the end, really important for scalability, for tier, is done if we have consistent interfaces here between these, let's say, perspectives. And with this, I hope you could get a little bit more of our ideas, of our insight. And I'm happy now to present Mr. Jan Reich.